Given question, find the forces developed in wires supporting an electric fixture.
Let us understand how to draw the free body diagram when the system is in equilibrium. If we observe the given diagram, the weight 150 Newton is connected to the point B. The wire AB as well as BC is having common point B. So I will make here one construction, that is for these two wires as well as for the weight 150 Newton, common point is B, and therefore I will draw one horizontal line and one vertical line passing through the point B. So this line will be in the form of dash and dot. Now we will understand the different forces that are related to the system. Now we know that this weight 150 Newton will always act in vertically downward direction and passing through the point B, because weight is connected to the point B. So for the free body diagram we have to show this. So we will also draw here one horizontal line as well as vertical line in the same way, and this point of intersection is nothing but the point B. Now at this point B we will show the weight 150 Newton, which will act in vertically downward direction. Now because of this weight is connected to the point B and this point B is also connected to the wire CB, then what will happen? It will tries to pull this wire in downward direction along this line CB, and therefore wire also apply the resistance force in the opposite direction. So opposite direction, that means upward direction along the line BC. So we have to show this. So how to draw here the line BC? Now if we observe this diagram, here this is the horizontal line and this is also the horizontal line. So these two lines are parallel to each other and BC is the common inclined line. So we have to show the opposite angle. So these two are parallel line, BC is the common line, this angle is 60 degree which is making with horizontal line, then this angle is also equal to 60 degree. So in the same way we have to show the one line, inclined line, which is making 60 degree angle with the horizontal. So I will show here. Here is the 60 degree angle and the direction of the tension created in the wire, that is in the upward direction along this line. So here is the tension T. So the tension for this wire BC, I will say tension T1. Now we will move next. Now for the next, if we observe, here is the wire AB. So for this wire AB, because of the weight 150 Newton, this weight will tries to bring the wire in the downward direction along the line AB. So what will happen? This wire is also applying the resistance force but in the upward direction or opposite direction. So we have to show this. So how to draw this AB? Now if we observe, it is making an angle of 45 degree with vertical. This vertical line and this vertical line passing through center are parallel line and this is the common inclined line. So here is also angle equal to 45 degree because these are the opposite angles. So in the same way we have to show here. So with this vertical line we have to show 45 degree angle. And tension T2 is created in this wire AB and here is the angle 45 degree. Now if we observe these three forces passing through the same point B, that means these are concurrent forces. System is in equilibrium. So when the system is in equilibrium by three forces, then we can apply the Lami's theorem. So according to Lami's theorem, that force is proportional to the sine of angle between other two forces. Now we will find out the all the forces in between, all the angles in between these three forces. Now it is very easy that if we observe, this is the horizontal line and this vertical line perpendicular to each other. So this total angle is 90 degrees. So 60 plus 30 is 90. So here remaining angle is 30 degree. Then here this angle is 45 degree. So remaining angle is 45 degree. And this angle is 90 degree. And this angle is also equal to 90 degree. Now we will apply the Lami's theorem. So according to Lami's theorem, first I will take tension T1. So T1 divided by sine of angle between other two forces, that is in between T2 and 150. So T2 and 150 angle is 90 plus 45. 90 plus 45, which is equal to, next is T2. So T2 divided by sine of angle in between other two forces, that is in between T1 and 150. 90 plus 60. 90 plus 60, which is equal to, now this 150. So 150 divided by sine of angle between other two forces. So T2 and T1, sine of angle of 45 plus 30. 45 plus 30. Now we have to solve this and then we can find out T1 and T2. When we calculate, then T2 is 77.6 Newton and T1 is equal to 109.8 Newton.